So we're just going to quickly go over. I forgot to write a title. Sorry.
Sir, for that test, were there like a few decimal answers? Yeah. Alright, good.
Quickly going to go over domain and range. And what I'm going to do is we're going to go over domain and range of a parabola, and then we're going to specifically refer it to this question. So we're going to apply it to something realistic. So, first of all, this parabola, it's x and y. First of all, actually, sorry, its domain values. The domain of the entire parabola, say they've given us some function for this, is just xer in terms of what its x values will do, because it will go to the right forever and to the left forever. Nothing will stop it. Okay? And in terms of the range of the parabola, well, it touches y is element of all real numbers, but there is a restriction. The restriction here is right here, and it is a downwards facing parabola. So at 8, that's the highest point. So y would have to be less than and equal to 8. Okay? So that is our domain and range. Now that's of the entire parabola. Now, let's say this question is what we're actually referring to. A ball is thrown, and this graph represents the path it is taken. Now we have to actually figure out where the ball existed in time. Okay? Let's say time is our x value. So our x value is measured in time. And our y value is measured in height. Maybe it's meters, and the other one's seconds. So we have meters. I know I'm putting a lot of things up here. Seconds. Okay. Now, if I'm throwing a ball, does its flight exist before I release the ball? No. So when does its flight first start? Which is at what point in time? 0. So this is when the ball first exists. When does the ball, it goes up in the air, hits a maximum point. When does the ball stop traveling? When it hits the ground. Okay? So the rest of this parabola technically becomes irrelevant for this question, because the ball does not exist at this point in time. It doesn't exist in flight before I've thrown it. And yeah, it's definitely not some kind of drill that flies through the ground. It stops at the ground. So if I'm talking about the domain and range of the flight of the ball, I'm talking about the domain and range only of our highlighted part here. So that changes things a little. Our domain, we'll do this in red. Our domain is going to exist between what 2 points then? Yeah, so where it was released was at 0, and when does it hit the ground?
So at 0.
Okay, so like we were saying, the domain, x is every real number, and it exists in terms of seconds. It's thrown at 0 seconds, and when does it stop? At
0.
Not 0. When does it hit the ground?
Oh, 8.
8 seconds. So x exists where x is greater than and equal to 0 and less than and equal to the number 8. Okay? So that is the domain of this ball. The range of this ball. Talk about the lowest and highest point. What's the lowest point here?
8. 0.
Talk about y now.
4.
The lowest point?
8. All 1.
0.
What?
0. When the ball is on the ground, 0 meters above the ground, it's at 0.
I said all the time, and then you still kept asking.
I know,
And then-
I was like 0, and you're just like, no, what's the lowest point?
Okay, and then the highest point. The highest point here, again, let's say it's in meters, is 8. So they happen to be the same. But the point of this is so you can realize that if we're applying it to something in real life, we have to think about what actual path it will take. Now, the equation of this clearly goes on forever, but a ball's flight only exists since when I throw it to when it hits the ground. So there's going to be restrictions on the domain and range of the flight of this ball. So anytime you get a word problem like that and they ask you domain and range, you have to think about whether it's a rocket flying, a plane taking off and landing. It only exists in flight for certain points, and then it stops because it doesn't go through the ground, or it doesn't start flying -10 seconds before it starts. That doesn't make a lot